Hello everyone, I want to share with you some of the oxidation reduction most important concept by using this online PDF file that you will see on my screen. So here is the first thing that I want to review with you. The definition of oxidation, as you can see here, oxidation is when any species lose electron, and one example of this is on this reaction here. Zinc is going from the oxidation 0 to oxidation 2 plus. You need to know how to calculate the oxidation number, and I will show you later on how do I know that zinc is 2 positive. You can memorize it, but I think the best way will be um, to find or to know the way to find the oxidation number. And reduction is the gain of electron. And for instance, copper here, the oxidation number of copper here is 2 and it's going from 2 to 0. So the oxidation number is decreasing. So this is the first two important concepts that you need to know in oxidation and reduction factor. The other important thing is always both reactions take place or occur together. In other words, if you have an oxidation, it should be a reduction happening at the same time. So there cannot be oxidation without reduction and vice versa. The next important concept that you need to know are the following: reducing agents and oxidating agent. Let's go over them. Reducing agent will be the substance that causes another substance to reduce. For instance, on this example here, zinc is experimenting oxidation because it will go from 0 to 2 positive. So zinc will be acting as a reducing agent because it's oxidating itself. But copper is going from 2 positive to 0. So copper is being reduced. So copper is acting as an oxidizing agent because it's provoking that somebody else will experimenting oxidation. In this case will be zinc going from zinc 0 to zinc 2. Another important concept will be finding the oxidation state of any species. Let me pick sulfuric acid here. Let me write the formula on this place here and see if I can show you how to find the oxidation number of any species. Let's say you don't know the oxidation number of sulfur and you want to find the oxidation number of sulfur in this sulfuric acid. You have to remember that hydrogen in most of the compound will have a positive charge, one positive one, and oxygen in oxide is always 2 negative. So how can I find the oxidation number of sulfur? I will multiply 2 times 1 positive, I don't need to write again the plus sign, plus the unknown. I have only one sulfur, so that will be 1 times x will be x. And then I will multiply also the number of atoms of oxygen times the oxidation number plus 4 times, and I will write the negative because I need to know that the oxidation number is a negative. So that will be equal 0. Why equal 0? Because sulfuric acid is not an ion, it's a neutral molecule. So that will be the formula of the sulfuric acid. So solving for this will be 2 plus x minus a equals 0. 2 and negative a will be negative 6 equals 0. So x will be, let me write here, x will be 6. So the oxidation number of sulfur in sulfuric acid will be equal to 6. That's the way you will find oxidation number in any formula. Another important concepts are galvanic cell and electrolyte cell. In galvanic cell, the process is taking place spontaneously, so the free energy will be delta G will be less than 0, that will be spontaneous. And the way you will produce is that combining two electrode or two, let's say it can be two different metal like a zinc and copper, and one of them will release spontaneously, will release electron, provoking that the other one will reduce, and that way you can make a spontaneous process. They have a bridge that will connect that, and I will explain you that using a real graph. The other redox process that we have to know is the electrolyte cells. In the electrolyte cells, delta G will be less than 0. Sorry, delta G will be greater than 0. And let me get the eraser. Delta G will be greater than 0, and that will be non-spontaneous process. Delta G greater than 0. So this is, let's stop here to make the video short, and then I will go over another topics.